Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Alandi, Pune. Today's discussion topic on demonstration of convolutional neural network for multi-class classification. In previous session already we have completed how we are using the CNN model for the binary classification. For binary classification, we have discussed the case study of pneumonia detection based on the chest X-ray images, and there are two types of classes that are normal and pneumonia classes. Now here we are extending this same notebook for the multi-class classification. Now here we are classification. We are demonstrating this CNN architecture for classification or recognition of facial emotion based on the facial images, face images. Now we are using these importing these libraries to implement this example. Now, as already we have discussed how we are importing the Kaggle environment in our Google Colab notebook. Here I have copied the API from the Kaggle for data set, that is a FER data set. Now here you can see in 4 data set there are total 7 classes. Now angry, disgust, fear, happy, surprise, sad, neutral, these are the 7 classes. Now whenever input is face image is given, at that time the task for this demonstration, that is to recognize the facial emotion of the person. Okay, now this facial emotion, it will be it can be as a part of any one class like angry, disgust, fear, happy, surprise, sad and neutral. These are the images present in a test data set. Here you can see there are 2 folders, test data set and train data set. Each folder contains 7 folders. In each folder there are the images with respect to that class. Now here these images from the Kaggle dataset are downloaded. Then after unzip you can use this image for the pre-processing purpose. Now here you can plot, then you can complete the image pre-processing task and list out all images in all folders. Now here you can display the images along with its label. Now associate these images present in with respect to folder and assign the labels to these images. Now here these are the images, display the total number of images count in train folder. Now after that we are using the data augmentation to increase the training sample. Using the image data generator you can increase the sample. Here for this example only one function is used to increase the data set, training data set size, that is a horizontal flip is equal to true. Now here once we complete this data augmentation, now here we are applying this data augmentation function using flow from directory function for the training and test data set, and here target and completing the pre-processing here only. Now here target image size is 48 by 48, as image size is already declared initialized, that is a 48. Means whatever images we are using in CNN model for the training purpose, the image size should be it will be reshaped to 48 by 48. Grayscale, this, yes, color mode is grayscale. These are not a color image, so here color mode is equal to grayscale. Batch size is equal to batch size. The batch size is equal to 64. Means during the training the batch size is equal to 64. Means one batch there will be 64 images are there. Class mode is equal to categorical, because in categorical because there are total 7 categories, and shuffle in every epoch these images will be shuffled. Same we are applying this function for the test data set. Now there are total 28,709 images for the belongs to train class, and 7,178 image available in test data folder. Now here we are using the CNN model. Now in CNN model we are using the sequential model, and in sequential model we are adding the number of blocks. In this example we are adding 3 convolution block. Okay, in every convolution block we are adding the number of filters, stride value, padding, input shape, and performing the activation and max pooling layer. Also we are adding the dropout layer in convolution layer to deactivate the features to avoid the overfitting. In first convolution layer block, there are total 64 filters are used, where its size is equal to 3 by 3. Input image size is equal to 48 by 1, as it is the color image, gray color image. Batch normalization is used to normalize the values which are generated by the previous layer. ReLU layer applied after the normalization. Max pooling 2D layer is applied after the ReLU to reduce the dimension of the feature map generated by the convolution layer. Then dropout layer is used. Here 25% of features are deactivated using dropout layer. Now here in this example we are adding 3 convolution block. In last convolution layer there are 512 filters are there, means there are total 512 feature maps are generated, and these feature maps are flattening using the flatten function and convert it into one linear vector. After the flattening, we are adding two fully connected layer. In first fully connected layer, there are 256 neurons are there. Then we are using the batch normalization, ReLU, and dropout. Here we are deactivating 25% of neurons in fully connected layer 1. Same convolution layer, fully connected layer block 2, where 512 neurons are there, and deactivating neurons by dropout. Next, after adding 2 fully connected layer, last layer, dense layer, is called as output layer. Now in output layer, we are, as this is the example for the multi-class classification. So instead of binary, we can use here softmax activation function. And in last output layer, we are adding the number of classes. There are total 7 classes, so number of neurons are 7 in output layer, and activation function is equal to softmax. As the softmax calculate the probability with respect to all 7 classes for the given input, and the probability of all these 7 classes, addition of probability of 7 classes, it should be 1. And we are predicting detecting that image belongs to that particular class if that probability is highest among the 7 probabilities. Here for compile, we are using one optimizer that is called as the Adam optimizer. This is the best optimizer. Generally, we are using Adam optimizer as it gives the better accuracy as compared to the other optimizer. Whenever we are using this Adam optimizer, you can set that learning rate, that is a 0.0005. Okay. Now the model dot compile, we are compiling this model using this optimizer, and here we are using the loss is equal to categorical cross entropy. In previous discussion, we have used the binary cross entropy whenever we are implementing this CNN for the binary classes. Okay. Here we are using the 7 categories, so here we are using loss is equal to categorical cross entropy. Next, matrix is equal to accuracy. Now here you can see this the summary of the convolution model, where you can see these are the outputs which are after the every layer. Now you can see after first convolution layer, these are the features. There are 64 features are generated for first convolution layer, where its size is equal to 24 by 24. And total 64 feature maps are generated. Same for the last 512 feature maps are generated, where its size is equal to 6 by 6. After applying last convolution layer, after max pooling, the size of final feature map is 6 by 6 by 512. Means total 500 features, these maps it is converted into one linear vector which consists of this many pixels. Then we are adding fully connected layer and 7 neurons in a last output layer. Now this is about the summary. Now here we are training this model. Now here the batch size is equal to 48. Now here the total number of images available in trained data set and validation data set divided by batch size. So number of validation epoch, steps per epoch we can display. Now here we are training our model. Also in this example we are storing saving the weight of the model. Once you train your model successfully, then you can save the model weight so that you can utilize this model for the unseen data set. So the time will be saved once you train this model, as it is this .h5 model you can use for the unseen images. Now after completion, now here epoch is equal to 1. Now we are trained this model for 1 epoch. Now here you can display the accuracy. This accuracy is very less, only for demonstration purpose. So epoch is considered as 1. You can increase this number of epochs so that your accuracy will be increased and loss is also decreased. Now for this example, approximately 20 epoch you can train this model for 20 epoch. Now this is the train accuracy for the 1 epoch whenever your model train over 1 epoch. This is all about how we are training, how we are using the CNN model. In this notebook, we have we have discussed how we are using the CNN model for the multi-class classification, and here we have considered the 7 classes. Now you can also update this notebook by adding the other data set, and you can update the size of images accordingly. Thank you.